This video will cover connecting and calibrating a system. Before we connect to our system, we want to be sure that the IP address for our GigaNet or PoE switch is set properly. We do this by opening our Network and Sharing Center. If you have multiple network connections, be sure to click on the one that goes to the Vicon switch. Click on Properties and then go to IPv4 settings. Verify that your IP address is set to 192.168.10.1 with a subnet of 255.255.255.0. This will allow the software to connect to the switch. Let's go back to Blade and connect. At the top left, you will see a connect button. After you click that, wait for the system to connect to the switch. You'll notice as it starts to connect, in the perspective view, the cameras will start coming in. Also, in your capture view, you will see the 2D camera image for each camera that is connected to the system. After all your cameras are connected, you should have a 2D camera image for each camera. Now we need to calibrate our system so the cameras know where they are in relation to each other. To do this, we need to open our calibration editor. Here are all the necessary buttons and settings to calibrate the cameras. Before we get into the calibration editor though, we need to check our camera settings and be sure they are set properly. To do this, in the capture view at the top there are a couple different buttons. We want to click on the Show Settings button here. You will notice 4 different bars appear. Each bar represents a different setting. The first is strobe intensity. Changing this value will increase or decrease the effective brightness of the strobe, which will affect the distance and clarity at which the cameras will illuminate. Next is the threshold. This is the minimum value at which data is registered by the pixels on the camera sensor and considered for circle fitting. If you reduce the threshold value, the amount of data passing through the sensor is reduced. Gain is the next bar. You can imagine it as an amplifier. Increasing the gain will make the marker have less variance in intensity from the center to its edge. Lastly is circularity. This determines how strict the system is on determining if a grayscale blob is a well-formed marker. The higher the value, the more strict the system will be on the circularity of that blob. This could result in a marker not being circle-fitted. To adjust these settings, all you have to do is move the mouse over the bar you want to adjust, and while holding the mouse down, you can change the values. You will notice after I moved camera 1's strobe intensity that none of the other cameras were affected. We can affect all cameras by clicking the button Affect All. Now, when I adjust a setting, all the cameras will be affected. For now, we're going to keep the strobe intensity at 1 and leave the other settings at default. With our settings complete, we are now going to start calibrating the system. First, clear everything out of your volume, and be sure there are no reflective markers visible. I've cleared everything out, but in my camera images you still see some white reflections. Those are the other cameras. This is okay as we are going to tell the system to paint those sections of the camera and ignore any data that comes through that part of the sensor. To have the system start this process, we click the Start button next to Auto Threshold. You will notice all those white reflections have disappeared, and now I have a black image for all my cameras. Once all your cameras receive the same results, go ahead and hit stop. We now need to do what is called a wand wave. Right below auto threshold there is an arrow you can click that will drop down some more settings. We want to be sure to have the correct wand selected. If you click the drop down box, you will see a list of different wands to use. In this video we are using the active wand Y up 5 markers. Select the correct wand for you. The one setting that is important here is the refinement frames. These are frames that are saved by the camera in order to calculate their positions relative to each other. What this means is, when 2 or more cameras see all 5 markers on the wand, those cameras will save that frame. We want to try and get all the cameras to save at least 1,000 frames each, which sounds like a lot, but will get saved rather quickly. The rest of the settings can be left at default. If you have someone to help you, then have them step into the volume with the wand and click Start Wand Wave. You will see my colleague walking around the volume trying to cover as much as he can while waving the wand. At the bottom of the calibration window, you will see each camera and how many frames have been saved. You will also notice a nice rainbow color effect in the camera view indicating where those cameras saw the wand. As each camera gets closer to the desired refinement frame, which was set at 1000, it will change color, green indicating that it has reached that amount. Once all the cameras have reached their respective refinement frames, you can stop the wand wave. The system will then start calibrating and placing cameras relative to each other. You can see this by looking at the perspective view. After it's complete, you get an indication of how well the calibration went. Awesome is the best you can get, with bad being the worst. If you get excellent and awesome, then your calibration was very good. Now we need to tell the system where the origin is. Where it says Set Volume Origin and Axes, click the drop-down arrow to get more settings. Again, we need to tell the system which wand we want to use to set the volume origin. We will select the same wand that we used for waving. It doesn't matter where you place the wand in your volume, as long as 2 or more of the cameras can see it. For the active wand and 5 marker passive wand, the way the system determines the orientation is as follows. X will come out of the left of the wand, Z is coming out of the top of the wand, and Y will be up. After you place the wand where you want it, click Start on Set Origin and then click Stop. All your cameras should look correctly orientated in the 3D perspective view. The last step is to calibrate the floor plane. I'm going to switch to an orthographic view to better show the slight adjustment that this will make. My colleague is going to place 4 markers in the volume in different areas. You'll notice in the perspective view there aren't any markers or visual indications that there are markers in the volume. I can change this by going to the top left up to the drop box that says Circle Fit. When I click that, I get some more options. I want to tell the system to reconstruct the markers in real time. This is going to allow us to see the markers in the 3D perspective view. After I turn that on, I can adjust the display size of the markers in this text box at the top of the 3D perspective window. You can tell that 2 of the markers are above the floor plane slightly, and 1 is slightly below the floor plane. We can fix this by clicking the Start button next to Calibrate Floor Plane and then hitting Stop right after. You'll notice that the markers rest evenly on the floor plane now. The system is now fully calibrated. Thanks for watching. If you have any questions, please email support@vicon.com.